We are Team 13, Team YAMS. Our first team presentation topic is energy from fusion. Our objective is to provide a brief explanation about the grand challenge of energy from fusion. Secondly, we use two journals, Journals of Fusion Energy and Journal of Engineering for gas turbines and power, to get an understanding and get to know more about the grand challenge. Lastly, our objective is to get an understanding of what is happening in the field of energy from fusion of late. The outline of our presentation is as follows. We first introduce the topic, define fusion, and lay down some fusion facts, which will be spoken by Austin. Matthew will then continue with the fusion facts and lay some interesting topics related to this field of late. He will finish with laying information about what we have extracted from the first journal, that is the Journal of Fusion Energy. Lastly, Yefyan will take over explaining the information from the Journal of Energy for gas turbines and power, and will conclude the presentation.
The sun is the biggest source for fusion of energy. What that means is that the sun is basically a large natural ball of fusion energy in space. Fusion is why the sun is so bright and full of energy. All the stars currently known by humans are like this. The fact that fusion is so dangerous is the main challenge to harness it commercially. The atoms in the sun are all super excited and constantly hitting each other so powerfully, the nuclei converge on one another like a giant, self-preserving atom bomb. Einstein famously measured the fusion energy in his equation, E equals mc squared, which I'm sure you've all heard of, where E is the energy, m is the mass, and c squared is the speed of light squared. This eventually led to the creation of the two atom bombs dropped on Nagasaki and Hiroshima. So back to the sun, as it is the best example of fusion in our solar system. It converts 600 million tons of hydrogen into helium by slamming the nuclei together. To put that into perspective, that's the weight of 15 million semi-trucks just in hydrogen. So, the humans took this example and are now experimenting with the isotopes of hydrogen, deuterium and tritium. However, the challenge again is replication. The reactions require immense heat of 150 million degrees Celsius.
Fusion facts continued. There are many different types and variations of machines that have been created to harness energy from fusion. These include tokamaks, stellarators, and reverse field bench reactors. Many countries have fusion energy programs. These include the United States, Russia, Japan, and the European Union, just to name a few. The energy and light that are output from the sun and stars are a product of fusion. What's going on currently with energy from fusion? It has been found that the most efficient way to generate and contain plasma is by using super powerful magnets. Many of today's reactors are being built using this concept. The most recent reactor configuration has increased the output energy by 16% over older models. The ITER tokamak, which is currently under construction, will be 800 times bigger than any reactor to date. Magnets that will be used in this new reactor will weigh about the same as a Boeing 747. Journal of Fusion Energy. This journal provides information about harnessing energy from fusion. One article states that generating fusion energy has been dominated by physicists. It argues that an engineer's approach may be able to develop more efficient systems because engineers think differently and use different processes. New discoveries in fusion may be used by engineers to create the most feasible fusion reactor to date.
The Journal of Engineering for Gas Turbines and Power Summary. This journal provides information about energy generated from gas and steam turbines, nuclear system engines, and power generation from the burning of fossil fuels. The research paper included in this journal, Fossil Energy, gives a description of how plasma is generated and used to create energy. It describes much of the physics behind energy generated in a tokamak-style fusion generators. And the facts in this journal is that if people want to use plasma as a reliable energy source, it must be extremely clean. This makes it very challenging to find an efficient design to keep the plasma clean. There are three known ways to generate plasma. One is omog heating, second one is nuclear burn injections, and the third one is electromagnetic heating. So the conclusion for this project is there is a big scope of energy to be generated from fusion, and even though this conception is in its infancy, it has a lot of advantages, and is quite exciting. If energy things goes well, this conception of energy from fusion can do wonderful in the coming years.